So before going into the classification chart of the different pressure relief devices, let's talk about what are the ultimate objectives of a safety relief valve and what are the desired characteristics of an ideal safety relief valve, if there was even such thing as an ideal safety relief valve. At the end of the day, that's the whole point of having different pressure relief devices on the market, because you'll find that each of them have a particular advantage over another. So obviously the objectives of a safety relief valve is you want to make sure it adheres to the local, state, and national governmental regulations, because as I said, after all of these incidents and deaths that have occurred in the past, you have these standards that were adopted by governmental regulations and are now code, and you need to make sure that you follow them so that you don't get fined, so that you don't break the law, essentially. And obviously, the objective of a safety relief valve is that you want to protect the operators from overpressure accidents. You also want to minimize material losses. So once safety relief valve activates, you want to make sure that whatever is contained inside the vessel isn't all spilled out. If it's your raw materials or if it's your valuable products, you don't want to lose that, because that converts to a lot of financial losses. And also at the same time, if the material inside the vessel is hazardous, you don't want to have hazardous material just being released to the environment, because that's unsafe. Also, you want to limit operating downtime. You want to be able to run back your plant as soon or as quick as possible. You want to protect the financial value of the equipment itself. You don't want to have your equipment damaged, and so that's why you set the pressure of the relief valve at an appropriate pressure, and we'll go through all of that together as we go through the different standards. You want to also make sure that the neighboring equipment are protected, and when you mitigate all of these overpressure incidents and you mitigate catastrophes, you'll have a lower overall insurance costs on the plant. And finally, you want to preserve the environmental safety and reduce any hazardous conditions within the facility. Now, what are the desired characteristics of an ideal safety relief valve? Obviously, you want to maintain a leak-free state until the set pressure is reached. However, as we go in depth in this course, you're going to learn that the pressure relief valves, usually before reaching the set pressure, they start to simmer. And that means they start to release the fluid, a little bit of fluid, before the set pressure is reached. And obviously, you want this safety relief valve to open exactly at your set pressure. Sometimes if you don't perform maintenance, or if the seat wears and tears, you will find that the set pressure might have changed. You want to make sure that the pressure relief device you're using discharges a minimum amount of product. And you want to make sure that it closes again within determined limits. So usually these pressure relief valves, once they open, they don't close back when the pressure of the vessel goes below the set pressure. It usually closes at a pressure lower than the set pressure, and that obviously drives innovation in the whole pressure relief device market. So when you have newer technology that comes out that closes the disc of a pressure valve at closer to the set pressure, that would be more desirable. You want the pressure relief device to be stable without shattering or cycling, unaffected by any pressure losses in the inlet and outlet piping. And I'll show you what are the rule of thumbs or ways to design your pressure relief valve and the discharge system to avoid the shattering or cycling of a pressure relief valve. And I'll describe what they mean more in detail as we talk about them. You want the operation of the pressure relief valve to not be influenced by any back pressure. What you'll find is there are different categories of pressure relief devices, whereby if you have high back pressure on the discharge line, then some pressure relief devices are more suited than another. And it also depends if your back pressure is constant or if it's variable. Obviously, an ideal safety relief valve wouldn't be influenced by that, but that's not realistically the case. And you want the ideal safety relief valve to allow for adjustments of the opening speed and blowdown settings separately, but you'll always find a compromise. As the opening speed of the valve is faster, you'll find that the blowdown, which essentially the blowdown, I'll talk about that in detail, but you can think about blowdown as the closing pressure of the valve. So you'll find that as you adjust the valve parameters so that the opening speed of the valve is faster, you'll find that the closing pressure is then lowered. So ideally, you want the valve to open very quickly, and once the pressure inside the vessel goes below the set pressure, you want the valve to immediately close, but that's not the case. You want also a valve that facilitates for straightforward maintenance, and obviously you want the valve to meet the different standards out there. So the ASME, which is the standard in the United States, and the Pressure Equipment Directive is the standard in the European countries. However, you wouldn't find one valve that meets all of these different standards. There's some nuances and differences between them, but this is the ideal safety relief valve.